Hi, geometry students. So this is the first video that I'm going to put together for you guys. We're going to see if this will help a little bit, just to bridge the gap with Agile Mind and the reading that you do and the lesson that you learn. So our lesson today is about reflections and rotations. This is the first of two videos that I'm going to create on this. Last topic was about transformations in geometry. Now we're getting specific with it on a coordinate plane. So we're going to develop some rules for reflections across the x and the y axis in this video. So you'll see this in Agile Mind. Like I said, last topic you learned about what a reflection is, how to reflect it across the line. Now we're going to actually reflect it across the x-axis and the y-axis, and we're going to look at the coordinates. So we're going to just experiment with this, and we're going to see what happens. This is done in some of the animations in Agile Mind, but I'm going to just kind of walk you through it, and we'll do it together. So we're going to reflect triangle PAT across the y-axis, which is the vertical axis. We're going to do this 1 point at a time. Okay, so we're going to reflect each vertex across the y-axis. Remember, reflection keeps the same distance between each point and the line of reflection. So the points are going to stay the same distance away from the x-axis or the y-axis. They're just going to be on the other side. So I'm going to start with P. P right now is 3 units to the right of the y-axis. It's going to stay on this horizontal grid line, but it's going to go 3 units to the left. So this is going to be point P. And then point A, same thing. It's 5 units away. So we're going to end up over here. And then point T, it's 4 units to the right. So when we reflect it across, it'll be right there. So here's point P, point A, point T, and I should be calling this P prime, A prime, T prime. So let's label those. So this is P prime, A prime, T prime. Let's go ahead and connect the sides here with lines, just with segments, so you can kind of see what's going on. There we go. So there is triangle P prime, A prime, T prime. Let's even throw in the coordinates of the vertices here, because I think we'll be able to notice something if we see the coordinates. So P prime is at -3, 2. A prime is at -5, 3. And then T prime is at -4, 6. So it might be helpful to pause the video and answer this question on your own, but what do you notice about the coordinates of the image? You should notice something right now. What I notice is that the y coordinate stayed the same and the x coordinate changed to its opposite. So I'm going to add that in here. The y coordinate stayed the same and the x coordinate changed sign. Okay. Let's do the same thing. Let's go across the x-axis. So same triangle, PAT, but this time let's go across the x-axis. So we're going to do the same thing, reflect them across, same distance away from the x-axis. So P is 2 units above. It's going to move 2 units below for P prime. A is 3 units above, so it'll move 3 units below for A prime. And then T, same vertical line, it's 6 units above, so it's going to move down 6 units below right there. Let's add in the sides now. And let's label everything. So this was P prime, A prime, T prime. In order to answer the question at the bottom, again, let's put the coordinates in here. P prime is at 3, -2. A prime is at 5, -3. And then T prime is at 4, -6. And then again, answer this question on your own. What do you notice about the coordinates of the image? I noticed the exact opposite this time. I see that the x coordinate stays the same. And the y coordinate changed sign. I was going to say changed to its opposite. We'll just say change sign. So let's summarize this. Here's a picture of everything that happened. Okay, P prime, A prime, T prime. They called it double prime when they went across the x-axis. So in Agile Mind, you'll see the double primes for that. But let's summarize. So let's drag and drop these to complete these statements. When we reflect it across the x-axis, xy maps to the point what? So x-axis, when we reflect across the x-axis right here, so we're talking about this reflection that ends up down here, x stays the same, but y changes sign to its opposite. Reflection across the y-axis maps the point xy to x changes sign, y stays the same. So there's a really nice summary of what happens when you reflect across the x-axis, and then what happens to ordered pairs when you reflect across the y-axis. There is another way to write this. So it can be described using an ordered pair rule, it's called. There's a notation for this that looks like this. So they just use this little arrow to kind of show that it like transforms into this. So here are the ordered pair rules for reflection across the y-axis. This means that an ordered pair transforms into this. So x changes sign, y stays the same. Across the x-axis, transforms into x staying the same, y changing sign to its opposite. So those are some basics on reflecting figures across the x and y axis on a coordinate plane and what happens to the ordered pairs. So I hope that helps you guys. Have a great day, guys.